Hey, 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 this is Mrs. Smith. This tutorial will be going over calculating neutrons. Here's a neutron. They have a zero charge. That's why it says no charge. To find neutrons, this is the formula I use, man. I have a little man holding the sign, his formula. The M in man stands for the mass of the element. A plus is the atomic number. I put the plus sign to represent protons. Protons is the atomic number. I subtract the two and get the number of neutrons. On the periodic table, the atomic mass is given to you. That's the bottom number on the ones that we use, or the number with the decimal point, the larger number. Then the atomic number is that whole number. It's the smaller number. On the charts we use, it's the one at the top. So that's where I get my information from my formula. My mass is here. My atomic number is there. I subtract the two and get neutrons. Now I like to use the formula this way because it's set up exactly how I'm going to plug my numbers in and subtract. So let's work a few problems. The first one is hydrogen. Hydrogen has atomic mass of 1.0079. I have to always round this number. So that rounds off to the nearest whole number of 1. So I'm going to plug that in for my mass. Hydrogen's atomic number is also 1. I'm going to bring that over there. That A plus, it has 1 proton. When I subtract the 2, I get 0. Now, how easy is that? 1 minus 1 is 0. Now, hydrogen is the only element on the periodic table that whenever I calculate the number of neutrons, it doesn't have any. Here's the Bohr model for hydrogen. So I see that 1 proton here. Remember, 8. Atomic number equals protons equals electrons. So atomic number in protons is 1. This is a neutral atom of hydrogen, so it has 1 electron. 0 neutrons. So this number is a decimal point for the mass. Remember, the mass is the protons and neutrons. So all the time hydrogen doesn't have 0 neutrons. It may occasionally have a neutron. That's how I got that decimal point there. Not very often. 1.00, but it can happen. So just be careful that if you have to calculate neutrons from the periodic table, here's the formula. Here you go. Use it. If it gives you a picture and asks for neutrons, you need to count the number of neutrons in the nucleus. So this would have 1, but most hydrogens have 0 neutrons. So be careful of that. Let's work another problem. Carbon. Now we went over carbon in 7th grade with Schnapps. It's organic. We're carbon-based because we're living things. So let's do carbon. Carbon has atomic mass of 12.011. I'm going to round that off and get the nearest whole number, 12. Now be careful. It doesn't always come out the same. Sometimes you may have to round up. Like you may round up to 13. So be careful. Now the atomic number or the protons is 6. So 12 minus 6 gives me 6 neutrons. Here is the Bohr model of carbon. So 6 protons, 6 neutrons, and 1, 2, 3, 4, 5, 6 electrons, like 8. So I say carbon is the evil element. It has 6, 6, and 6. Let's get away from carbon. Okay, our last one we're going to work is gold. Gold has the atomic mass of 196.97. Here is an example. When you round it to the nearest whole number, it now comes out to 197. So be careful. If you use 196, this calculation is going to be off by 1, and I guarantee you it's going to be one of the answer choices. Be careful. So 197 is the mass. 79 is the atomic number, or the number of protons. I'm going to use a calculator for fun. Now, when I subtract the two, 197 minus the atomic number 79 equals 118. Gold has 118 neutrons. It works that way every time. Okay. So remember our cheerleaders did a cheer for man. Man, let's do it again. Mass minus atomic, how many neutrons is it? Hope that helps you to remember. Talk to you later.